Welcome back for another deep dive. Looks like we're taking a trip back to geometry class today.
Always exciting.
It is. You guys sent in some really interesting stuff on Pythagoras' theorem and even included a resource from Open Educational Resources slash open source physics at Singapore.
Wow.
Yeah, and get this, it's a JavaScript applet that actually lets you see the theorem in action.
I'm intrigued. Visualizing these concepts can be so powerful, you know?
Absolutely. But before we get too far, let's back up for a sec for anyone who maybe needs a little refresher. What exactly is Pythagoras' theorem? You know, just the basics.
Sure. So, at its core, Pythagoras' theorem describes the relationship between the sides of a right-angled triangle.
Okay, so we're talking triangles. Got it.
Right. Specifically, right-angled triangles.
Oh,
And it states that the square of the
hypotenuse.
hypotenuse, yeah, which is the side opposite the right angle,
Right, right.
is equal to the sum of the squares of the other two sides.
Okay. So in simpler terms, if you square the length of the longest side of a right triangle,
Exactly. The hypotenuse.
right, the hypotenuse,
Right.
it'll be the same as adding up the squares of the other two sides, no matter what the triangle looks like.
That's exactly it. And it's true for any right triangle, which is pretty amazing.
It is. And this website we got, it's dedicated to providing open access to educational resources. That's fantastic.
Absolutely. Making education more accessible is crucial.
So tell me more about this applet they created. How does it work?
Well, imagine being able to actually play with a right-angled triangle on your screen.
Like, virtually.
Yeah, you can resize it, make it taller, wider.
See how the angles change?
Exactly. And the applet shows you those squares forming on each side,
Hmm.
proving that the theorem holds true no matter what.
Whoa, so you can visually see how the squares of the two shorter sides always add up to the square of the hypotenuse?
Precisely. It brings the concept to life.
And they even have this thing called a draggable box, right?
Oh yeah, the draggable box, you can use it to manipulate the shape of the triangle. Makes it
Yeah.
really interactive.
Yeah. So cool. Sounds like this applet moves learning beyond just memorizing formulas.
It does. It helps you understand the dynamic relationship between the sides of a right triangle. It's not just some static rule in a textbook, you know.
You're actually experiencing it.
Exactly. And the website mentions some other cool features too.
Like what?
Well, there's a full screen mode, so you can really immerse yourself
Nice.
and, play, pause, reset buttons.
So you can control the pace.
Yeah, it makes the learning experience much more personalized, like having your own little geometry lab.
That's awesome. So we've got this amazing website dedicated to open educational resources, offering a hands-on tool that lets anyone explore Pythagoras' theorem. It really makes you wonder, what are the bigger implications of having resources like this freely available?
Hmm. Well, I think one of the biggest impacts is that it democratizes education.
Mm.
It makes complex concepts accessible to anyone with an internet connection.
So it levels the playing field.
Exactly. And it empowers those who might struggle with traditional learning methods.
That's powerful. So it's not just about free access, it's about inclusivity and reaching a wider audience.
Exactly.
This really showcases the power of open educational resources, fostering a deeper understanding and making learning more engaging.
Couldn't agree more.
But I'm curious, where do we actually see Pythagoras' theorem at work outside of a textbook?
Oh, it's everywhere. In architecture, construction, navigation.
You're kidding?
Nope. Knowing this theorem helps us build stable structures, design maps, even create computer graphics.
Wow. So we're not just talking about some abstract math concept. It literally shapes the world around us.
It really does. And that's what I find so fascinating about this applet. It connects the theoretical with the practical.
Okay, so we've covered the applet, its features, and the impact of open educational resources. But let's dive deeper into those real-world applications. Give me some examples. Where can we see Pythagoras' theorem in our everyday lives?
All right, let's start with something simple. Have you ever hung a picture frame? Well, guess what? You're secretly using Pythagoras' theorem. To make sure it's level, you're basically creating a right triangle and using the theorem to ensure it hangs straight.
Really? I never thought of it that way. So this basic math concept is secretly working behind the scenes all the time.
It is. And it goes way beyond picture frames, too. Think about using a map to navigate.
Yeah.
You're basically using triangles to figure out distances and plan your route.
Oh, like those little distance markers.
Exactly. And of course, then things like construction and engineering, knowing this theorem is like essential. Like you need it to calculate lengths, angles, and make sure everything is structurally sound.
So we're talking about everything from hanging a picture to like building a
I
skyscraper.
got it. It's everywhere.
It's like, I don't know, a secret code or something, like a key that unlocks the understanding of how things fit together.
I like that. It's INES, like a hidden language for shapes and spaces.
Yeah.
And the more you learn that language, the more you start to see all this elegance and order in the world. Pretty cool.
Okay, so we've got the basics of the theorem, we've seen the super cool applet, and we've touched on some of the real world stuff. But what's really interesting to me is how this applet kind of changes the way we think about learning.
Totally. Math, and especially geometry, has always been about, memorizing formulas and all these abstract concepts.
Yeah.
But tools like this applet, they're all about a more like visual and experiential way of learning.
It's not just reading about it in a book, it's actually getting to do it. Like, it's like the difference between reading about how to ride a bike and actually riding one, right?
Exactly. It's
Yeah.
hands-on. You're not just taking in information passively, you're actively engaged, you're changing things and seeing those results right away.
And that's what makes it stick, right? That's when it clicks, makes those abstract ideas seem more concrete and relatable. It reminds me of when I was in school trying to wrap my head around geometry. It wasn't until I actually started picturing those shapes and how they relate to each other that it started to make sense.
Yeah, I think that's pretty common. Our brains are just, wired to process visual information really well. When you can actually see something, it's way easier to get it and remember it.
It's like that aha moment, like, oh, now I get it.
Exactly. And that's why I'm so excited about these interactive learning tools. They can help us connect that theoretical stuff with real-world understanding.
It's not just about making learning easier, it's about making it more meaningful, more connected to what we actually experience.
For sure. It's about really appreciating how cool and powerful math can be. And that's something everyone can benefit from, no matter who they are or what their background is.
And it brings us back to that whole idea of open educational resources. It's not just about giving people free access, it's about creating a more inclusive and fair learning environment.
I totally agree. Breaking down those financial barriers and offering these engaging interactive tools can empower people from all walks of life.
It's about recognizing that everyone, everywhere, deserves the chance to learn and grow.
Precisely. And I think open source physics at Singapore and groups like them are doing amazing work to make that happen.
I'm curious, from your perspective, what are some of the other benefits of having resources like this out there for free? Like, what impact do you see them having on the future of education?
I think we're just getting started, honestly. Imagine if anyone, anywhere, could access these top-notch materials and tools, no matter where they live or what their situation is.
Wow. It'd be a world where learning never stops, where everyone has that opportunity. That's pretty exciting.
It really is. And I think open educational resources are going to play a huge part in that. By encouraging people to work together, to come up with new ideas, and to share their passion for knowledge, we can create a better learning experience for everyone, one that's more equal and more enriching.
So we started by breaking down a single math theorem, then we explored how it shows up in the real world, and now we're talking about the future of education. Pretty amazing how one idea can lead to such a big discussion.
It is, right. It just goes to
Yeah.
show you how connected everything really is. When you start digging into those connections, you never know where you might end up.
And that's what makes learning so exciting.
Absolutely. It's a journey of discovery. And the more we can share that journey with each other, the better it becomes.
I think we've done a pretty deep dive into Pythagoras' theorem and the whole world of open educational resources. What do you think is the most important takeaway for our listeners? For me, it's that learning doesn't have to be stuck in, textbooks and classrooms. It can be way more engaging than that and available for everyone. And this applet is the perfect example of that.
Yeah, totally agree. When you have tools that are this easy to use and this interactive, it opens up a whole new world of possibilities for how we can learn.
It's all about getting people curious and then giving them the power to explore these ideas in a way that really works for them.
Exactly. And it helps people develop a love of learning that can last a lifetime. When we can break down those barriers and make education more exciting, we open up so many opportunities for everyone to grow, both individually and as a society.
So you've all gotten a taste of Pythagoras' theorem today, and not just as some boring formula. You've seen how it's a dynamic relationship that you can actually play around with.
And you've seen how these interactive tools and open educational resources can completely change the way we learn. For the better, I think.
Absolutely. So that wraps up another deep dive. Thanks for joining us.
And one last thought as you go about your day. See if you can spot examples of Pythagoras' theorem at work out in the wild. It's everywhere. From the layout of your house to how bridges and skyscrapers are designed, it really is a fundamental principle that makes up so much of the world around us.
Pretty cool, right?